All right, guys, in this video in the series, Unlocking the T-Distribution, we're going to be talking about how to do a two-sample t-test when you have independent samples manually. Okay, so remember, we're going to go through each of the different types of t-tests. I'm going to show you how to do it manually, hopefully build some intuition. And then after that, I'll be posting the rest of the series, which is the implementation in Python and the implementation in R, where we'll see the use case examples. So stay tuned for that. So let's go ahead and jump into this problem. We've got a researcher who wants to determine if there's a significant difference between the mean scores of two different groups. So we have two different groups, and they're independent. But the two groups are from a population of students who took a standardized test. Okay, so we've got two different groups from one population, and group A has a mean score of 75, standard deviation of 10. Group B has a mean score of 80 with the standard deviation of 8. Okay, this has a random sample of 20 students is taken from each group, and we want to test the hypothesis that there's no significant difference in the mean scores of the two groups using the 5% level of significance. So in this case, why are we going to use a t-test? Well, in general, the common usage wisdom indicates that if you have a random sample of less than 30, then you should use a t-test. Although I have to point out that if you dig into some research, I think you might find that in this case, the z-test might not give you much different results, okay? But generally, if you get asked this question on an interview or something, somebody's going, you need to answer less than 30. Okay, so that's the general idea. We've got two different groups, and we have the mean samples. We have the sample mean from each group. We have the sample standard deviation from each group, and our sample size is less than 20. So let's go ahead and jump into this. I'm going to switch screens here. And we'll go ahead and start taking down all the information we need and write down our problem here. Oops. Okay, so we're doing a two-sample t-test. We have independent samples. Now, they're independent because they're two different groups, okay? If it's not two different groups, then that's what we call a paired t-test, which we'll get into in the next example. All right, so for group A, we're just going to write down our statistics for each group. So for group A, we've got sample mean of 80, right? No, it's 75, sorry. Sample mean of 75 with the standard deviation of 10. And of course, our sample size is 20. And so for group B, we also have all this information. We've got mean score of 80 with the standard deviation of 8 and a sample size of 20 as well. Okay, so our alpha level is 0.05. So remember, what does the alpha level set? This means that we'll have a 5% chance of a type 1 error, okay? And we can go ahead and set up our null and alternative hypothesis. So our null hypothesis is that there is no significant difference. So that if we look at the population mean of these two groups, they'll be the same. So that means since our null hypothesis is that there is no difference, so in other words, that the two groups come from population with an equal mean, then the alternative hypothesis is just the negation of that, which in this case is that they're not equal. Now, anytime you see where we have equals and not equals, we have a two-tailed test, as opposed to when we have less than or greater than. Anytime you see less than or greater than, or less than or greater, or I'm sorry, less than or equal to, or greater than or equal to, that's going to be your one-tailed test. The minute you see this equal, not equal, we have a two-tailed test, which means that if we look at our distribution, we need to check the lower tail and the upper tail. So like this. So our 5% significance level needs to take half of it from the lower tail and half from the upper tail. And that's going to be our regions of rejecting the null hypothesis. So in other words, we need to take our alpha and divide it by 2 to get 0.025. So 0.025 is going to correspond with the probability that we get the probability that our p-value is here or here. Okay, so we've got a 2.5% probability that given the null hypothesis is true, that we'll get a p-value in this region or this region. I think that's right. Is that right? Sure. So anyways, we're going to calculate the area under both of these sections here. And that's going to account for our, hold on, I think this is a little bit strange. Let me write it like this. So on this side, we've got 0.025, and on this side, we have 0.025. So add them together, we're going to get our 0.05, which means that in the middle here, so in this region, let me just give it a different color. In this region, this is our 95% region here. Okay, so the blue region, right? So if our p-value, if our t-value is in the blue region, then we would fail to reject the null hypothesis. But if our t-value is in the red region, we would reject our null hypothesis. Okay, and now let's calculate the p-value using the p-value method. So what do we need to calculate that? So let me also, before I do that, let me do one thing here. Let me just move this over here for a moment. So what I'm going to do to calculate the p-value, so how is that going to work out? Well, we're going to end up with a t-score here that's negative and a t-score here that's positive, right? And so I'm going to calculate either from negative infinity to negative t of my t distribution PDF, or I'm going to, which is going to be the same thing, or I'm going to calculate from t to infinity f of t dt. And that's going to give me this, the area underneath this curve. All right, now this t-score, by the way, this t-score is not, it doesn't correspond to this. Okay, so this is just the reject region. Okay, whoa, what happened? So this is going to have its own p-value, which is what we're going to calculate here. But this p-value is only half, right? Because when you calculate from negative infinity to negative t, we're only getting the area up to negative t, whatever it is. And when you calculate from t to infinity, we're only getting that area. So what we have to do here is take our integral, whichever one we choose, and then multiply it by 2. And that will give us our p-value. Okay, and if this p-value, if p is less than alpha, then we reject the null. And if it's not less than alpha, we fail to reject the null. Okay, so let's go ahead and let me demonstrate how that is calculated using Wolfram Alpha. All right. All right, so let me just switch my screen here. And there we go. Okay, so here I've got my T distribution PDF here. You can see everywhere I've got my degrees of freedom in the right place. Degrees of freedom, degrees of freedom. And the first integral I'm going to do is I'm going to integrate from negative infinity to the left side. to negative t, which is going to be negative 1.746. Actually, you know what? I forgot to calculate that. Oh, so that's the t-square. Let me go back and show you how to calculate that. Looks like I forgot to do that part. Oh yeah, so we need to calculate the t-score. All right, so let's go back over here. So when you have a two-sample t-test, in order to get the test statistic, we have to do like this. We're going to take mean one. Oops, let me try that again. So we'll get mean one minus mean two divided by S1 squared divided by N1 plus S2 squared divided by N2, and then take the square root of that. All right, and then, so in our case, we're going to get 75 minus 80 divided by 10 squared over 20 plus 8 squared over 20. And then we take the square root. And when you do this calculation, you're going to get negative 1.746, which is what I just had shown on the previous screen. Okay, so now let's go back to our screen over here. Okay, let me just do one thing here. So I'm going to go back over here to Wolfram. And now that we've got the t-score, we can calculate. But actually, I'm going to go back up to this graph. So now this graph is, we can replace these t's, right? So we know what these are now. And we don't know like we don't know the area that it takes up yet. So, but we'll just consider this red region to be whatever the area is. So that means that here it's going to be negative 1.746, and then over here it's going to be 1.746. Okay, so so if our p-value is if our p-value ends up being, when we integrate from negative infinity to here, negative 1.746, 1.746. If our p-value is less than 0.05, then we will reject the null hypothesis. But if it's not, we will fail to reject the null hypothesis. So let's go back over to Wolfram now that I've shown you how to calculate that. You can just use this formula here. Okay, anytime you have the two-sample independent t-test, you can use this one right here. This formula here. Okay, so now let's go back over to Wolfram. So first I want to integrate from negative infinity to the left bound, the lower tail rather, 1.746, and let's see what we get. So we get 0.044446. Now remember, we need to multiply that by 2 because we're talking about two different tails, right? But before I do that, let me just prove to you that actually, if I do for the upper tail, I'm going to get the same result. Okay, so let's get rid of this. And we'll just go like this. So now I'm going to integrate the upper tail from our t-score to the upper tail here. And we're going to get the same result, right? So 0.0046. Now remember, that's only half of it. So we have to add those two areas together, or we can just multiply them by 2 since they're symmetrical. And we're going to get a p-value of 0. So I'm going to write that over on this other screen. So we have p-value equals 0.088 0.892. Okay, so using the p-value method, we've already reached our conclusion here, which is that the p-value is greater than alpha. So that means that we fail to reject the null hypothesis. Okay, so does that mean that the alternative hypothesis is true? No, it means that the evidence supports the evidence is no, sorry. The evidence supports the alternative hypothesis. And what am I saying? No. We failed to reject. The evidence supports the the null hypothesis. Meaning that there is no difference, right? Now, is it possible that there's a mistake? Yeah, it's possible that so there's a 95% probability that the null hypothesis is true. And there's a 5% probability that it's false, right? So that's the type, that would be the type 1 error, right? So we can't accept the null hypothesis. We can say that it's there's a 95% probability that there is no significant difference between the two means. So if you're in a business analyst position and you're calculating which customer segment you need to give attention to based on those two mean values, you could see that you don't need to spend any more money on any one group because there's no significant difference in the mean values. So whatever it might be, in this case, it was the students taking the standardized test. So, you know, even though that group B had a lower, was it group A? Group A had a lower mean test score. They don't really need more attention than group B because there's no statistically significant difference in the mean scores, right? So you can divide your resources equally. Whereas if we had rejected the null hypothesis, then the insight generated that we can apply to make a business decision, to make a decision in allocating our resources would be that we need to allocate more resources to the group with the lower score, right? If the null hypothesis had been rejected. Now, again, there's not a 100%, there's no 100% here. This is all probability. So if you're explaining that to stakeholders, you might not want to mention that there's still a 5% chance that it's false, right? Because maybe they're not interested in knowing the details, the subtleties, right? So now let's go back to looking at the second method. I'm just going to explain that and then we'll wrap up the video. So the second method, of course, is our Tcritical method. So to get our Tcritical, what do we need? We need our degrees of freedom, which in this case is 38, and we need alpha. But in this case, we have a 2-tell test, so we need alpha over 2, which is going to be 0.025. So we can use this to look in our t-table. And what will happen is like this. So let me draw the picture here. So in our distribution, we'll have our, okay, so we're going to have our T star critical and our T star. Okay, so let's say it's here. And if our T score that we calculate already is between these two, then we fail to reject. But if the T, so if the T score, which in this case would be negative T score, if it's in here, this is the reject region. Okay, and if it's in here, then it's also reject region, positive T. So in other words, if it's in, what is this? So if it's in here, then it's going to be fail to reject region. Wow, that's like a really big, what is that? Oh, I wonder. Okay, hold on. Okay, so if it's in between our two T criticals, that's our fail to reject region. Okay, so if we've got negative T critical less than T, which is less than T critical, we will fail to reject. In any other case, we will reject. Okay, so how do we get our T critical? Again, we need to go to the T table. So let's go ahead and do that. And I'm going to use the same one from the University of Utah page. All right. Okay, so we need degrees of freedom 38. So here's my degrees of freedom 38. And we need a 0.025. And so we go down here and we're going to get where the intersect is 2.024. Now remember, this chart, make sure you remember when you look up the T-scores in a T-table, pay attention to the legend here. So this is giving me the upper tell. But remember, we're doing a two-tell test, so that this is going to be plus and minus 2.024. Okay, so that is my critical T. So it's going to be, let me write it over here. Plus and minus 2.204. So my T critical plus or minus 2.204. And then my T value was negative 1.746. So certainly this is in the interval, the open interval from negative T star to positive T star, right? And so let's go ahead and take a look at what this result is. All right, so let me go here. Okay, so what I can see here is that we calculated our T critical to be from negative 2.02, so that's the left side, and then 2.02 is the right side. And the T score that we got, which was negative 1.746, and here I just called it 1.75, it's in between these two, right? So it's in the fail to reject region. So that, you know, there's evidence to support the null hypothesis, which is that there's no significant difference in the mean values. Okay, so that's going to be it for this video. In the next video, we're going to be discussing, I'll just show you, two sample t-tests with paired samples. So when you think about paired samples, we're just thinking about, basically you can think about a before and after type of situation like this. Okay, so that's coming up in the next video. I hope this helps. If you notice any, if you have any questions, if you have any suggestions, and if you have any, if you notice any mistakes, please mention it in the comments. Thanks for watching, and I hope this helps.